This is a solved problem for deterministic push-down automata. This is a given language 0 power n and 1 power n. As it is, we are setting n is equal to 1. We are getting 0, 1 and 2, 0, 0, 1, 1, 0, 0. So it goes on like this. And first we know what is deterministic PDA. Here deterministic PDA means here if you are going to read one input for starting with Q naught, then the input is maybe A, so it may be reaches with only one state, either Q naught or Q1. Okay, so this state must be a unique, so this is called deterministic. The same scenario we have to apply here. Already we have seen in finite automata, non-deterministic as well as deterministic finite automata. Here the same thing we have to ensure that while implementing the rule. Okay, first thing we have to start with the initial state. Definitely the starting string may be 0 and ending with 1 only. Okay, so maybe equal number of, not maybe, it should be the equal number of a's for zeros followed by equal number of ones. So we have to analyze before going to construct. If it is 0, if you are reading 0, what will happen? If you are reading 1, what will happen? If you are reading the input is 0 and the stack symbol is Z0, what will we do? So like that we have to analyze first. Here as it is, they given the equal number of n's. Okay, it is a dependent only. So if you are going to push the n zeros into the stack, and again n ones going to pop from the stack. Okay, that is you are going to match the strings zeros and ones. Okay, so that we need to write rule as per this. Okay, so initially we are always start with Q naught. You are going to push the value, we are going to read the value 0 means stack symbol is Z naught, as it is you have to push. Okay, so definitely the stack symbol may be Z naught, otherwise it may be after pushing this one value at least, the stack symbol at the top of the stack symbol may be 0. So if it is 0, what will happen? You have to think it, and both are 0, you have to pop the value. And again you have to read the next characters. If it is a input is 0 and stack symbol is 0, so it is a different characters. Here the same character, here different. Okay, if it is different, you have to change the state also and make it the stack is empty. Still again you have to read one more, 1 means again the stack symbol is 0, so you have to pop. Okay, still the same state. So keep on we are doing. At one junctions we are getting the empty state in the input buffer, so Q1 and empty, then the stack may be empty, so we can represent, we can switch over the another state Q2, then stack also empty. So this is way of writing, way of framing the rules for, it will support for n greater than or equal to 1. We can set n is equal to 100 also, 200 also. The same 5 rules it's applicable for all n. So here we have to ensure it is deterministic or not. You see here Q naught 0, we are getting Q naught maybe. Here Q naught 0, again we are getting Q naught only. Q naught 1, we are getting Q1. Again Q1 1 only, we are getting Q1. Okay, so the same input, we are getting the same state, that's all. So here, yeah, all state must be in unique. So here the input is 1, but the state is different. Yes, Q naught 1 is Q1 and Q1 1 is 1. So here this two input is same only, but we are having different state. Yes, Q1 1, Q1 and Q1 epsilon. Okay, so definitely the state must be unique. Anyway, here we are using the two input the same. Here but state is Q0 to Q1 and Q1 to Q1. Okay, so this is a deterministic PDA. So now we have to ensure this is a transition diagrams. If it is 0, is it not, the outcome is you have to push these values. If both is 0, again you have to push. If you are reading the 1 and stack symbol is 0, you make it as a empty, but you have to switch over from state to another state. Here you have to ensure whether it is 1 and stack symbol is 0, you make it as empty, and again it will reach the input buffer as empty, stack is Z0, you go to the final state. So this is a way of representing the transition diagram. Next one is we have to ensure whether the string is accepted or not as per the rule. So this rule you only framed. Okay. So Q0 0, you have to push the value into the stack. Again Q0 0 0, you have to push the value into the stack. You have to ensure Q0 1 0. There are different characters. You maybe change the state and remaining value will be there. So different characters, you make it as a empty. You have to pop the value from the stack also. Finally it will reach the final state. So this is a way of checking using this extended transition. We can say it is called a delta. That's all. So this is a way of constructing deterministic finite automata. Thank you.